To recapitulate, the common atrioventricular canal is partitioned by the simultaneous proliferation of the endocardial cushions, the muscular interventricular septum, and the interatrial septum. The septum secundum produces the foramen ovale, with the septum primum acting as a membranous valve. An opening persists between the ventricular cavities. Closure of this interventricular foramen awaits the elaboration of a complex spiral septum, which splits the truncus arteriosus and conus region into the aorta and pulmonary artery. The formation of this partition is more clearly seen if the heart is turned by 45 degrees. Originally, the right and left ventricles share a common outflow channel, the truncus arteriosus, which gives rise to the aortic arches. The truncus arteriosus is presented schematically as a transparent cylinder. The bifurcation of the truncus arteriosus, illustrated here, represents two of the aortic arches. The fourth aortic arch forms the aorta, and the sixth is the origin of the pulmonary artery. A pair of ridges which develop at the bifurcation spiral down the truncus arteriosus. They fuse along the axis of the cylinder to produce a single spiral septum, extending down towards the ventricles. The interventricular foramen is obliterated by masses of endocardial tissue from the ventricular septum, by the endocardial cushions, and by the spiral aortic septum. The partitioning of the heart into its component chambers and corresponding arteries is now complete. The significance of the spiral aortic pulmonary septum is more readily appreciated in a frontal view of the heart. The aortic pulmonary septum executes a spiral of 180 degrees and swings into line with the superior margin of the interventricular septum. This process accounts for the manner in which the aortic and pulmonary trunks are entwined in the fully developed heart.